Hey guys, this is Mr. Beckstrom, and today I'm going to do a problem, an example from section 4.1. So it says determine the location and value of the absolute extrema values of f on the given interval if they exist. So what this is this is some function on the interval from 0 to pi. 4 sine squared of x. So the absolute extrema are the highest points and the lowest points, the highest y values and the lowest y values on this interval here. The first thing I like to do whenever they're asking for either the absolute or the local values is go ahead and put that into our calculator and go ahead and set our window with whatever interval they're giving us just so we can get an idea of what values we're looking for. So go to the calculator, go to y equals. Now remember, when they do sine squared of x, that's just shorthand for sine of x quantity squared. So it's much easier to write it as that. Now, there might be a way to write it like this in there, but I always do it like this. So I'll do 4 and in parentheses, I'm going to do sine of x, and then I'm going to do that like that and squared. And this means the same thing as that right there. And make sure that your mode is in radians, or this is not going to work there. Go to your window. Make sure, I already changed mine, but make sure your x values go from 0 to pi, just 0 to pi. Your y values, I just left mine -10 to +10. You might want to change that after looking at the graph if it doesn't fit. Go ahead and get your graph. And so it looks like we're capturing all the highest and low values. So it looks like the lowest values are probably going to be around y equals 0 at the beginning, at the end. And I'm guessing at x equals 0 and x equals pi. And then right in the middle, probably at pi over 2, we have our highest y value. So I don't know what that's going to be, but we'll find out. Now we have a function to figure out what those values are in our calculator, but obviously we want to use calculus, so let's do that. All right, so how do we figure out where those are? Well, if we remember, if we find the first derivative of this function, that gives us the what? It gives us the equation for the slope of the tangent line. And then if we set that equation equal to 0, that'll show us wherever we have a tangent line with a slope of 0. And that will show us where we have any kind of peaks or valleys here, right? Peaks and valleys. And for the extrema values, we have to check our peaks, our valleys, and our endpoints. Our peaks, our valleys, and our endpoints. All right, so let's go ahead and find the derivative. For sine squared of x, I can either use the product rule or the chain rule. I think the chain rule is going to be a little bit easier here. So let's go ahead and do that. So if I write this like y equals 4, and I do sine of x squared, then applying the chain rule, this is just going to be 4, apply the derivative of the outer function, so bring the 2 out front, so that's just 2 times sine of x to the power of 1 times the derivative of the inner function. The derivative of sine of x is cosine of x. And I think that's going to be a little bit easier than doing this as a product, because that's sine of x times cosine of x plus cosine of x times sine of x, and you'll just end up getting 2 sine x cosine x and then multiplying it by the 4. So either way, you should get this right here. So now if we set this equal to 0, oh, there should be a little multiplication there, so that's going to multiplication there, which means I have to erase this. So if we set this equal to 0, because we want to find out where we have that horizontal tangent line, where the peak and valleys are, so 0 is equal to 8, sine x cosine x. Really, all we have to know is where is sine of x or cosine x equal to 0, and that's simply where x is equal to what? Sine of x is equal to 0 between 0 and pi, at 0 and pi, and cosine of x is equal to 0, or x is equal to 0, cosine of x is equal to 0 between 0 and pi at pi over 2. And look at that, they happen to already include our endpoints as well, so I don't have to tack those on. So these are the only 3 points then that I need to check, right? So let's go back up to our calculator here and put in those 3 endpoints, and if they happen to be our highest and or lowest y values, those are going to be extreme values. So let's go to second graph, and remember, if you go to second window first, you want to make sure your independent is on ask, your dependent is on auto. So it asks your x value, and then it automatically gives you your y value. Go back to second graph. So 0 we put in there, pi I put in there, and pi over 2. Second pi divided by 2, and we get that value. So let me check that. Let me go back to y equals 4 sine of x squared. Something seems a little bit off here. Oh, I think I put an e there instead of pi. That's what I did. Second pi. Yep. So here we go for 0 and pi. We get the value of 0. So those are our mins, our extreme minimum values. And then for pi over 2, we get 4. So that's going to be our maximum value. All right, so that's it. So we have a minimum value of 0 at x equals 0 and x equals pi, and we have a maximum value of 4 at x equals pi over 2. All right, I hope this helped. If you have any questions, let me know, and have a great rest of your week. Thanks.